Okay, so now let's talk about electron configurations. So electron configurations are our way of figuring out what orbitals electrons exist in the ground state for an atom. Okay, so what we're going to do is we're going to look at energy levels, and we're going to fill the lowest energy orbitals first. Remember, we can only put 2 electrons in each orbital, okay? And so we're going to use up arrows and down arrows to represent each electron. And then if we have multiple sublevels, so like say we have a set of p orbitals. Remember, we have 1, 2, 3 different spatial orientations for our p orbitals. What we do is we put in 1 electron at a time, and then we go back and spin pair. So say I have 4 p electrons. I would do 1, 2, 3, 4. So I always put individual electrons in first before I go back and spin pair. Okay? So our energy, we're going to go from 1s to 2s to 2p to 3s to 3p. And then here's where it gets a little bit weird. Then we go to 4s, but then we go to 3d. Okay, so we fill 4s and then we go back and fill 3d. Then we go to 4p, 5s, 4d. Okay? So here's another image of it. So 1s to 2s, 2s to 2p, 2p, 3s, 3s, 3p, 3p, 4s, 4s, 3d, so on and so forth. Okay? This is another image that some people like to use. But what I actually like to do is just look at the periodic table. Because the periodic table is actually broken up into sections that correspond with how all these things fill. So period 1 will fill our 1s. So there's 1s, there's 1s. All right, that's done. Because remember, an s orbital only has the 1 orientation, so I can only do 2 electrons in it before I'm done with my s orbital. Okay? All right, now I'm going to move to period 2. I'm going to fill my 2s electrons, and then I'm going to fill my 2p electrons. So if you look, we've got groups 1a and 2a, so that's 2 across. Oh, that accounts for s, because I can fit 2 electrons in s. When I look, from boron over to neon, so groups 3a, 4a, 5a, 6a, 7a, and 8a, oh, well, let me count 1, 2, 3, 4, 5, 6. Oh, it's 6 across. We can fit 6 electrons in our 2p orbitals. So there's where that 6 comes from. All right, now that's full. Now, when you've heard of the octet rule, well, what is 2 plus 6? Oh, 2 plus 6 is 8. Okay? So the octet comes from filling the s and the p electrons. All right, so I'm going to drop down to 3. Now remember, we're going to fill 3s, 3p. We don't fill any d electrons in period 3. Now those d orbitals exist, and when you get to 141, you're going to learn about what kind of consequences the fact that the d orbitals exist in period 3 have, but we're not filling them in period 3. We're going to come down to period 4. Now we'll fill 4s, okay, and then we'll get into our transition metals. Now if you count the transition metals are 10 across. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Remember, there's 5 orientations of d orbitals. Okay? We can fit 2 electrons in each of the d orbitals, which means that we can fit a total of 10 electrons. All right? Okay, and we'll, fill that. Then we fill 4p, then 5s, 4d, 5p, 6s, and then we get into our lanthanides and our actinides down there. Okay, so we'll fill 6s, we'll start 5d, but then we'll drop down to 4f. Okay? If I count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. There's 14 across with our lanthanides and our actinides. Well, there are 7 spatial orientations to our f orbitals. Okay? 7 times 2 is 14, so that's why that's 14 across. All right, so the periodic table is going to give you a really good way to remember how everything is filled.